Now, when I work with people individually on ACT stuff, okay, and I usually can get a kind of an idea of where they're at, right? If they're like someone who can barely spell their own name, like I'm kind of focusing on these, you know? If they're like right, you know, in the middle, I kind of focus on some medium ones. But what I want to do with you guys today is we're going to focus on the difficult questions. When you're taking the ACT, in fact, if you practice a bunch over and over and over again, sorry, like I'm working with someone right now that consistently gets 1 through 40 correct every time. Usually misses like 3 in 41 through 50, and usually misses like 8 in 51 through 60. Like every single time, you know? And so what we're going to do is I would just go over those last few questions and try to teach them tricks and things like that, okay? Well, then we'll look at some of those too, and you're fine. But I want to show you guys 41 through 60 because none of them are more difficult than what you guys can do. You guys just need to talk to you about a couple things, okay?
This frequency chart.
Okay. 41, this one's not too bad. A lot of this, I don't know why I started talking all of a sudden. Guys, a lot of these questions are very doable, reading charts, graphs, whatever. Take a minute and see if you guys can do 41. Think about what it's saying, okay?
Well, yeah, we sent the...
Okay, we're just looking at 41. One of the things that we talk about, you guys, is like, know where you are on the test. If you're in questions 1 through 10, and it gives you a chart, you're probably just reading the number directly off, right? If you're on question 41, you're probably not just looking and going, oh, 13 and marking it, right? There's something else a little tricky to it. There's one word in here that makes this thing a little tricky. What is it?
Cumulative.
Cumulative. It's like annoying. I've never seen a chart like this, but okay. So 12 people got between 65 and 70. 13 got between 65 and 80, which means how many of those got between 71 and 80? One extra guy, and that's it. You know, 19 got 65 to 90, so 81 to 90 was an extra 6 people. So it's like cumulative, right? Kind of lame. 91 to 100, there was an extra 2 people.
Who makes a group, like a chart like that?
I don't know who would ever, but there you go. What if I said how many people are in the class, or how many people are in the, you know, range?
Me test graders.
21.
Do a chart like that.
Yeah, it's weird. Okay, what's the point, right? Okay, this question, you guys, a lot of times you're given an equation, and like, a lot of times something that I feel like I get hung up on is I don't understand the problem, but because it's the math section, it doesn't really matter if you understand the problem or not, you know? So it's talking about like decibels from an audio source and intensity and constant and blah, blah, blah. And I'm like, what is going on? Okay? Because I could barely read, but I can math like crazy. So check it out. I have a formula. All right. How many decibels are produced by an audio source whose intensity 1,000 times K? All right? Intensity is 1,000 times K. Can you guys give me some numbers where the intensity is 1,000 times K? What should I use?
1001.
I like that. That's pretty straightforward. 1,001, right? Now what if I use 2,002 or 5,005? Because it was 1,000 times. It doesn't matter eventually what's it going to reduce to. 1,000. Now, can you do this faster on your calculator or in your head? What do you guys think? Yeah, some of you will be able to do it faster in your head, some of you on your calculator. Just type that in your calculator, tell me what you get. remember that you have calculators and you could use it for things like this. Okay, so, yeah, how do you do this in your head? Remember that if there's no base, it's log base 10. We're talking about logs right now in honors math 3. So like just this part, 10 to the what is 1,000? 10 to the what is 1,000? 3. 10 times 3 is 30. But you could always put that in your calculator too, okay? Do I have any idea what I just did? Not really, I just kind of followed the math, you know? I'm not thinking about sound decibels and stuff, it doesn't matter. All right, I think you guys can do this one, but remember, it's a question 43, so there's gonna be something a little tricky that some other people might forget to do. All right, see if you guys get this. Mario's playing basketball, and he has how many types of shots he took, the number attempted, percent successful. How many points did Mario make? Okay, guys, I got 213. Did you guys get 213? Okay, cool. If you got, hang on a second. Yeah, I'm about to say, if you got 129, you forgot that points are valued different ways, 1 point, 2 point, 3 points, right? So, again, that's what makes this a more difficult question. I go, what's 75% of 80? You do that on your calculator, that's 60. What's 90% of 60? You can do that on your calculator, that's 54. And then what's, 25% of 60, that's 15. But we're not adding those up because these are 1 point, 2 points, 3 points. It didn't say how many baskets, it said how many points, okay? So read carefully little things like that, and then remember, hey, I'm at the end of the test. These are going to be kind of difficult. Let me think through it and make sure I'm doing it right. Make sense? Anybody who's had me, I feel like you guys should get number 44 because we talk about this so dang much. All right? So it says the graph of the absolute value of x minus 6. Which of the transformations applied results in that? What do you guys think? So we talk about this a lot. Like if I asked you guys to graph that, would you know how to graph it?
Yes.
It's an absolute value.
Absolutely.
And what do we know about this absolute value? It's moved which way? Right 6. Now, if you didn't know, could you put this in your calculator and graph it? Absolutely. That takes time, though. All right? I'd rather have you remembering this. We talked about this before. X plus A plus B. Okay. Anything, no matter whether it's absolute value or x squared or, sine of x or whatever, the way it always works is anything in here, it's the opposite, and it will make it go right or left. Right, but if it says like minus, it goes to the right. If it's positive, it goes to the left. And anything out here is the same, and it goes up or down. Plus goes up, minus goes down. Okay? So if you remember your transformations, that's a pretty easy one. I have seen so many questions like 45. This usually comes up quite a bit. So let's think about this real quick. Okay? Toby wants to find the volume of a toy soldier. He fills a rectangular container. You guys, a lot of times I will just sketch this because it just helps me get an idea of what I'm doing. So I've got this rectangular container, like a fish tank. Okay, it's 8 centimeters long, 6 centimeters wide, 10 centimeters tall. He totally submerges the toy soldier in the water. Oh, I skipped a line. Hold on.
Wait, hold on. Why would you be so?
And he filled the water to a depth of 4 because Toby is an inquisitive child, and Toby is always thinking, and Toby's like, I wonder how many centimeters this toy soldier is. Do you guys know a Toby? Do you have a Toby in your life? Is Zachary a Toby?
Why am I a Toby?
I mean, I don't know. Did you ever measure the volume of your toy soldiers? Now, you guys, how much water is in there, or how could I find how much water is in there? 8 times 6 times 4? Cool. Now, I put my toy soldier in. All right?
Bro, that rises so much, actually.
And it rises to 6.6. So with the toy soldier in there, it's 8 times 6 times 6.6. Can you guys figure out how much the toy soldier is?
That's it. It's not anything complicated.
It's not anything complicated.
Why do we do this whole drawing it out? Why don't we just do that first?
I don't know, because I have to draw it out.
Sounds like it would take.
Well, I wouldn't draw it with such a beautiful stick figure, but still. So guys, if I go 8 times 6 times 4, the the water alone is 192. If I go 8 times 6 times 6.6, the water with the soldier in it is 316.8, and if I subtract those, I get 124.8. Does anybody want to yell at me about a better way to do this?
Yeah, without drawing all
Like
of
the
this
first
stuff.
equation, like the bigger one I know, just put minus
Yes. Or you could just say, well, shoot, Mitchell, look, it's only going up by 2.6, so why can't I just go 8 times 6 times 2.6? And you absolutely can. Yeah, that's fine. Okay? Okay, now, I'm going to teach you guys a strategy that I do. You know there's some people that just are good at multiple choice. It's like a skill. You know what I mean? And it's like, they could put a multiple choice test in front of me that's in like French, and I could probably figure out how to get a few right, because it's kind of a skill, right? Some people can like analyze it. So there's like one of the ways that I like thinking about multiple choice stuff. Listen, with math especially, before I read all this, I'm sure I'm going to need to read it, but before I read all this, I'm looking down here. What is this problem going to ask me to do?
With pi.
Stuff with pi, and pi makes me think of circles, and I'm like subtracting, and I'm not multiplying it out. So when you're in the problem, if you start going to your calculator and multiplying it out, you're going to waste some time, okay? Okay, check it out. Box shape of a cube. I'm going to draw a cube, Aubrey, because it doesn't take that long to draw a cube, right? And we're shipping a circular cylinder. So first of all, guys,
That was not.
just between, if you did not even see a question, between that picture and my answers, what could I cut out right away? It's not going to be either of those, right? Because it's 18 times 18 times 18. That's easy. Okay. Blah, 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 blah. Right circular cylinder. Does anybody know what a right circular cylinder is?
No.
Let's talk about those words. What does circular mean?
Circle.
What does cylinder mean? Like three-dimensional. Okay, we'll talk about right in just a minute, but it's basically a circle going into 3 dimensions. Okay?
Apparently, is it a sphere?
Like a Pringles can, maybe? Pringles can. Why is it a right circular cylinder? What do you think that word right is referring
I'm
to?
guessing it means that
not a this cylinder or whatever. It's not like
Parallelogram-esque cylinder.
exactly. So it's just a right circular cylinder. You guys, I can make a rectangular cylinder that just looks like a box. I could make a triangular cylinder. What's a triangular cylinder?
It's just a hollow.
Like that? Anybody seen a triangular cylinder before?
Oh yeah, Toblerone.
That's a Toblerone, absolutely. Oh, I love Toblerones. Okay, that's a Pringles can or a soup can or whatever. Now, I'm not going to necessarily have you guys memorize volumes. Okay, on the SAT they give you a formula sheet for volumes. They don't on the ACT. If it's a really complicated one, they might tell you what the formula is. But you guys, in general, here's how you find a volume, okay? And those of you that are in calculus right now, it's going to make a lot of sense to you, all right? Because look, we take the area of the base. So one-dimensional is like a side measurement or something, the area, and then guess what we do? We make another one, and another one, and another one, and we stack them up, and we stack them up, and how much do we stack them up? H tall. So it's just whatever the base is times height. So if it was a rectangle, it's the area of the rectangle times the height. If it was a triangle, it's the area of a triangle times the height. All right?
Oh, so it's just pi 6 times.
Exactly. That's all it is. So it says that it has a radius of 6 and a height of 12. So the area is pi r squared and the height is 12. Nope.
I was about to
I'm
say
just
that's wrong.
joking.
It's J.
Huh?
Or you could have just. That is the only one which are radius formula.
Exactly.
And it says 6, so you didn't need to do all the drawing.
Exactly. No, I
You
didn't
need to
do
do all the drawing.
No, but I'm teaching. So a volume is just a bunch of areas stacked up, okay? Now, let me tell you guys something. Just for future reference, do you guys know how it changes if it does this? What is it? You're right. No. Close though.
Wait, say the question again.
Okay, so this is pi r squared. What happens when it comes to a point?
That's the same as divided by 2,
Divided by 3. Pi r squared divided by 3. You can kind of see, like, doesn't the empty space kind of look like 1, 2, 3? Kind of. Maybe? So, like, if I had a... Here, you guys are going to find a line with this. Find a pyramid with a rectangular base, which is weird, right? Actually, instead of calling it BH, so it's called length width. I don't know.
Wait.
Length, width, and then the internal height of the pyramid is h. What would the volume of that be? Okay, so it's the area of the base times the height, and because it comes to a point, it's a third. Anything that comes to a point is a third. So you guys can get these
Triangles come to a
volumes.
point and it's 1/2. Just 2-dimensional.
Because it's 2-dimensional, but when it's 3-dimensional, it's a third. So in the 4th dimension, no, I'm just kidding.
So in the 4th dimension,
It would be a 4th if
That
it came
makes
to a
sense.
point. Ah.
I
But I
love
like
that.
that. Triangle
I like
comes to a point, it's a half. It's 2-dimensional. 3-dimensional figure comes to a point, it's a third. Yeah?
Yes.
That's kind of cool. All right, I like it.
Wait, so
Okay,
This is.
I would just basically say
This works so much better.
any cylinder is the area of the base times the height. And if it's a cylinder that comes to a point, like if you have a triangle and it comes to a point, the only difference between that and between my Toblerone is my Toblerone is the area of the triangle times the height. This is 1/3 area of the triangle times the height because it comes to a point. That's all.
Oh, boy.
Yeah. This is so easy if you do it the right way. I want you guys to think about this.
Oh, it's
Okay? If you go one way, it's really easy. If you go the other way, you do it wrong, basically.
Is the answer
The answer is, what'd you get? No, that's the wrong way. Good job.
Wait, what's the right answer?
Oh.
Oh.
That's.
The right answer is
Oh, it's
B.
Wait, oh, that's what you said.
Yeah, no, she said D. And I mostly just want to tell Aubrey she was wrong.
Now I know.
Okay, here's why, you guys. We know, so little things like this, the fact there's 3 feet in 1 yard, right? Little things like that, okay? So if you go this way first, you're going to get it right. 15 feet means 5 yards. 21 feet is 7 yards, right? Yards. And so it's 35 yards squared, okay? Now the way, and you might be like, dude, that's so easy. How could you possibly mess that up? Well, if you go like this first and you multiply 15 and 21 and then try to convert it, yeah, you get 315. And you try to convert it. If you only divide by 3, you're going to get 105.
Divide by 9.
You have to divide by 9. You got to divide by 3 twice because it's squared. So if you're converting singular units, divide by 3. If you're converting square units, got to divide by 3. Divide by 3. And what if you're converting cubics? You'd have to do it 3 times. Exactly. Okay.
So would it be faster to do 15 times 21
No. It feels
Doesn't matter. It's the same. I mean, a divide, a multiply, a divide, a divide. It's the exact
Depends on
same.
how you
Get smaller numbers. With
Yeah.
bigger
Yeah, because it's
numbers.
smaller numbers, you can just do it in your head. But
Exactly.
it's not.
Okay, I think that most people are going to look at this and be like, dude, what the actual heck? Although, I did show you guys step functions, right? Without even reading the question yet, see if you can understand or explain to me what this is saying.
It's a step function.
So it's a step function. We're going to it's called the greatest integer function or the step function. So how does the step function work?
No, here's.
And then it switches off the rate. You're exactly right. So for example, if I'm taking this cab and I go like 2.1 miles, I'm paying $6. If I go 2.2 miles, I'm paying 6. If I go 2.9 miles, I'm paying 6. But the second I go to 3 miles, I'm paying 8. Does that make sense?
Yeah.
That's how these step functions work, okay? Now that we know how it works, so this is kind of like a cab driver who's like, no change. We don't deal with change. We only do whole dollar amounts, okay? So now that we understand how a step function works, go ahead and read that and see if you guys can.
Oh wait, this is.
Okay, also, guess what?
It's just be extra easy.
None of that matters.
I just said I didn't read any of that.
You don't have to read anything on this one, right?
I read through the whole thing.
You can tell Von Clegg that reading words is stupid. You only have to just look at.
What he told us to do today is
And then you
memorize.
start adding graphs, suddenly I'll understand.
You go to him and he's all, you have to read every single word. And I'm like, skip 90% of that. Just read the last sentence. Right? Basically.
At one point, I always read the last sentence. The last sentence is
So
usually the
good, so
question.
good.
Now,
Yeah.
every once in a while you have to read the words, but
I just
Sometimes you just don't have
find
to
that
read.
easy stuff. Here's
Until
my
the English
question.
section.
exactly. And remind yourself you're in math. I'm not reading, I'm doing math. Okay. 5 miles. Do I stop here?
No.
I gotta go up to there, right? So that's $12. 5 miles. Do I stop there? No, I gotta go up to there. Whoop. Hello. $9, which is the cheaper fare, $9.
So what's the point of the whole if
Yeah, so what it's saying, actually, that's a great question. Can I answer it with some calculus words? The limit, as I'm getting close to 5, is from the left is 10. Meaning, if I go 4.9999999 miles, I'm still only paying $10. But the second I go 5 miles, I'm paying $12.
So the circle is just the smallest number
You
of
just like look at the graphs and see that like the second one's definitely gonna be cheaper. Just look at it.
Yes,
Okay, well then
honestly,
wouldn't it
yes.
have been smart for them to
Hey, it could say, all right. Here's the question I would ask you.
And and then walk like
At
the last
what
point.
point do you decide to take ABC cabs or Terry cabs? Is one always a better price?
No, it's when you hit 2 miles.
Is that what it is? Is that where
Is
the
it 2 miles?
breaking
2
point
miles.
is?
Goes to 6.
Because at
Or 2 miles, they're the same.
0 to 1 is 2, 0 to 1 is 4. Ooh, so this guy's cheaper. But then, like, yeah, 2 miles, that guy goes up to 6. 6. Oh, you're right. So if you're going a short distance, these guys are cheaper. If you're going a long distance, those guys are cheaper. That's the question to ask. That's a more interesting question. Okay, this is so fun, you guys. Check it out. The gravel book is the 3 line segments. Blah, 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 blah. What are we actually looking for? What is the area between those line segments and the axis? Hey friends, does that make us think of anything?
No.
Calculus?
Are we gonna make
Yeah, I mean, shoot, instead could I say, instead could I say what distance did you travel if that's a velocity time graph from time 0 to 5 hours? I'm just messing with my calculus people. Because that's exactly what we're studying right now. Anyways, can you guys find the area of that? Say again? That's exactly what you do.
So you like the triangles, rectangles,
Yep.
right?
Yep.
Make it a square.
Yep, no, it's not too bad. It's pretty easy. But yeah, when I saw this, I was like, oh, that's a calculus question. Right? Kind of. It's, if that's a velocity time graph, it asks you to take the integral, and the integral is the area under the curve. It's just something we've been doing all month. And it asks you to find the area of this. So it's really a geometry question, but we do it in calculus, so it's kind of fun. Since half this class is in calculus and the other half are taking it next year, right? Ashley, right? Right? Catherine, stop that. You can take it next year, maybe. All right. Huh? Yeah, no.
But you'll have Mitchell. That's what I want.
That's what everybody wants, let's be honest.
Yes. Why do I have to go take a class by some other kid?
I don't know, because I don't know stats. All right.
You should teach.
I know it's stats.
Actually, you probably
Okay.
don't do stats.
So, yeah, last period I did it like this, and then I was like, oh, that's like too many rectangles. If you remember trapezoids. But basically, I can break it up like that. 3 by 3, that's 9. That's got a base of 2 and a height of 1, so that's 1. That's got a base of 2 and a height of 3, so that's 3. 13?
Why is that?
Yeah, it's a base of 2 though, because it goes from 3 to 5, and it's a height of 3,
Oh, you're right.
and then it's 1/2 base.
What is the value
Yeah.
of the group?
That's not bad.
That's not bad.
How would you do this with?
At this point in the class,
What's that?
How would you do this?
Like that?
Like that, okay.
That's what we are supposed to be doing. It's just knowing that you're supposed to find the area is what the calculus part of it is. Alright. Alright guys, this question is important because I'm going to tell you that sometimes doing it the math way is not the best way to do it. Okay?
That's so cool.
It's an interesting question, but sometimes doing it the math way is not the best way to do it. Check it out. Can you guys help me write an equation for the sum of two positive numbers is 151?
A plus B equals.
X, Y, A, B, whatever, 120. Alright, I'll use A and B. My goodness. Now, which of those is less or bigger? Doesn't really matter.
Is that 121?
No, it's 150.
I know, but what is your?
With your terrible handwriting. It's getting worse.
Guys, I'm so tired. I worked through a lot of this week. Even though I took a mental health day, I still am like
I worked
recovering.
not at all this week.
You're taking a mental health day today?
I need a week in Mexico. You're welcome. My alarm went off, and I sat there going, why did I decide to teach these Saturday classes?
That's me every single day.
And then I was like, let me just look at TikTok for 5 minutes. And then I looked at it for 30 minutes, and I was like, oh, I really should go now. Anyways, that was my morning. I don't know how you guys did. All right.
That was my morning too.
And then it was like, oh, that's
I
fine.
woke up and hit snooze 4 times. I just stared at the ceiling.
I saw a TikTok about how bad it is to push news. Anyways, okay. The lesser number is 19 more than the square root of the greater number. What the heck? Okay, do I know which is the lesser number? Doesn't really matter. We'll use b.
19 equals square root b. Or,
Is
oh, wait, no.
equals,
Minus 19.
what is 19 more than?
Minus 19.
Plus
Square
19.
root of a.
Oh, it
Square
could
root
be-
of the greater number. Or something like
Wait,
that.
why is it square root?
Because it says square root.
Oh.
Right? Now, you guys, we've been talking a lot about systems of equations, you know, where you have two equations with two variables and you can solve it by elimination or substitution. And so I'm like, oh, systems of equations, I got this. Mitchell taught me this. I take b and I sub it in for b, right? And I get, okay, so a plus the square root of a plus 19 is 151. Yeah?
Subtract the 19. Oh.
Subtract the 19, a plus square root of a is
132.
It is.
132.
I can't do math.
Now, mathematically, how would you do this? How would you solve this?
Square. No, wait, you can't square both sides.
You can square both sides,
Can you? But what about the other a?
kind of.
But then
If you move the a over,
That's pretty awful, honestly. Like, so here's what I'm thinking. This is all wrong, by the way. Well, I mean, it's
This
not.
is wrong.
Algebraically.
Don't teach us wrong things.
I know, I'm asking you, though. That, I have to FOIL, though. Right? And so usually, if we were teaching on like a section, if I was teaching you guys about, oh, here's how you factor, here's how you solve radicals, I would tell you that it's actually a little easier if you bring the a over. I would teach you that.
Said.
Because then when I square both sides, I don't have a square root left over, yeah? So I would teach you that. This is still not the best way to do it, but
Stop teaching us this.
because I'm showing you, because I want you to see how to save time. When I FOIL that, I get these like massive numbers. I get like 17,424 minus 264a plus a squared, and then I gotta bring that over, and then I have to factor it. Like what? It gets insane, right? You think it's not factorable? It is. You can do the quadratic formula. All right, all right, all right.
Just a guess on the entire question.
You are exactly right, except for not really. Here is where you guess. Now,
I mean, I would guess and then mark it and come back if I had time.
okay, I want to know where a plus the square root of a is 132. And like squaring this and doing it the mathy way is just going to suck up a ton of time. Look at that real quick. Let's test some numbers. Now, if I'm testing a number, Zach, don't answer this too quickly for us, or any of you guys. If I'm testing numbers, I should probably test numbers I should take the square root of, right? Okay, give me a number you can take the square root of. Literally anything. Why is it what?
Plus 19.
What do you want?
19 is, or the number is 19 more than. The number is 19 more than. Okay, give me a perfect square you want to test. 25 is a perfect square. 91. You mean 81? What's 25 plus the square root of 25?
30.
That is so way too low. Give me another perfect square. 81. 81 plus 9 is 90. That's still too low. Give me another perfect square.
121.
121 is a perfect square. What's the square root of 121?
11.
And what's 121 plus 11? Whoa! Oh. So guys, what did I just solve for?
B.
There seems to be some confusion.
Wait.
Or-
We
or-
could have
wait,
just
sorry, I
looked for
put-
the
I have a
only
B on
answer
my
that
paper.
is a perfect
Oh,
square.
Yeah, so it's
Yeah,
right
well, yeah, okay, so wait, hold on though. Aubrey's like,
Wait.
I just solved for A.
There.
Woo! A is 121. So I go like this, right, Aubrey? 121, I move on.
That's not
No.
right.
If you are in the last 10 to 20 questions of the ACT, I do not want you to put an answer until you read over the question one more time.
That's J.
Okay? Okay, because look, I read over it one more time. Blah, 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 blah. What is the value of the greater number minus the lesser number? Oh. I found 121, but that's not the value of the greater minus the lesser, right? First of all, what is the lesser number?
30. I was right.
30. What is the value of the greater minus the lesser?
91.
Boom.
Yes.
Okay? Now, it really sucks because you can get like most of the way through the problem and get 121, and then you're like, cool, that's one of the answers, and you mark it. I like to do the same thing. You have to be careful. Listen, if you're in the first 10 or 20 questions, yeah, it's probably that. But if you're toward the end, they're trying to trick you, so just read it again. Okay? Okay.
Okay, but we still could have found the first number by just going. I guess no, this would have been wrong.
Yeah, see, the thing is, it's not like I could have just looked at these and guessed. There's like no way.
Yeah, but
Yeah.
it's very likely that they would have put that in as one of the options, and since it works, then you can test that one first.
Maybe.
Works, then you can
Maybe. All right.
strats here.
I think that you guys could get this. I want to give you a second to think about this. I think this is a really cool question. Because in order to do this question, you have to know what a mean, a median, and a mode is.
I don't remember what mode.
That's common, right?
Mode means most. Yeah, most common.
I remember
Median.
Median means middle.
Yeah. Median
So
is
guys,
middle. Median is average.
For my drivers, what do they call the thing in the middle of the road? The median, right? Because it's in the middle.
They call it that.
Yeah, like you're not supposed to cross the median when it's a solid yellow or something like that.
Nobody has ever called it that.
Everybody calls it that. Anyway,
No.
the mean is the average, mode means most. Let's do this question, see if you guys can get it. I believe in you.
They add does Mari?
It occurs the most often. So I have a list of numbers, and it's like, yes, you have to have two 15s basically.
Well, it could be 315.
And it could be 3 15s, exactly right.
So
Oh, because the mean is the one.
the median is 25, and so that's the middle number when you put it forward, right? And there is no 20, so there's an even amount. You have to average the two middle numbers. So, and you can switch out.
That was a pretty.
How do you do this?
Is there like a step after the step?
It can't, so one of the numbers has to be 15, the other one has to be 25. But it could be any number below 25.
No, you're not.
What did I do?
You're not thinking about the fact that the median is 25.
I am. There's 6 numbers.
If there's 6 numbers, Aubrey, how do you find a median?
I wrote 7. What did I do?
That's the.
Oh, wait. I counted 3 years.
Yeah, we got one for like half a year, and then they moved, and then
This one got actually. Wait, does it mean you have to put everyone?
Do you have an odd number of numbers?
Yeah.
If you have an odd number of numbers, that's your median.
But it has to be one of the numbers.
Yes. If you have an even number of numbers, your median is the average of those two. Meaning 25 is not necessarily one of the numbers, it just has to be between the two middle ones. So you have an even number of numbers.
This is where it's
Okay.
We just know it.
One thing I want to remind you guys really quickly.
So really, this is.
If you have an odd number of numbers, the median is the number in the middle. Okay? It has to be 1. But if you have an even number of numbers, the median is halfway between the 2 in the middle. So it doesn't have to be one of the numbers. It's just between, right? So here's what I did. First thing I did, I wrote this in order. I wrote, okay, 41, 35, 30. If there's a median of 25, it has to be right there. Okay? And I know that that's 15. And I have to fill in those other 2. But right now, can I fill in this one?
Yeah.
Because if the median is 25, what would it have to be?
20.
It has to be.
And the other one has to be
And,
15.
and why does that have to be 15? Because the mode is 15. I'm good. Now I just have to find the average by adding them all up and dividing this.
I know, and all of the rest of like all the addition.
Oh,
Just say it got period.
gross. So 15, 15, 20, 30, 35, 41.
I like caught myself on that. It was like a free response. So,
Yeah. Divided by 6, and I got 26.
like, what's the mean? 143.5.
What do you guys think? Not too bad? All right. I think number 52 is the hardest question on this practice test.
It is. It is hard. I'm working on it though. Progress is being made.
I just have a quick question for you guys.
Yeah.
When you see that pattern right there, something squared and then 4 something something, way back in the recesses of your brain, do you see that pattern anywhere in any math you've ever learned in your life? Let's go! That's the part of the quadratic formula, isn't it?
It is.
What's the quadratic formula, guys? What? What? Now, guys, that's how my mind works because, I don't know, I've been teaching math for most of my life. So I'm like, something squared minus 4 something something. Oh my gosh, that's the quadratic formula. That's specifically something called the discriminant. Have you guys ever heard of the discriminant of a quadratic formula? Okay, I'll talk to you about it real quick. But that's basically what I'm thinking of. Now, so that's one thing. Okay, that's one thing. Let's set this over here for a minute. All right. First step, though, y equals x squared. So I'm going to put that in right there, right? I can't do anything without doing that. So I have rx plus sx squared.
Oh, so it's ax plus bx.
Yeah, the ax squared plus bx plus c. Guys, one thing I'm going to tell you is if you have something with so freaking many letters and you're just like annoyed, and you try and figure out what you're supposed to do, what you could do is replace those letters with numbers. Just to kind of get the idea of what the problem's asking. What if this was like 1, 2, 3? Okay? 1x plus 2x squared equals 3. Do you guys know how you would solve that? If you were just on some equation and I gave you that and I need you to solve that, how would you do it?
How you count x?
So,
Factor the x out. That's the same problem we had last week.
Yeah,
If we factor out the x, we're saying that anything that multiplies to make 3, either that makes 3 or that makes 3. That's not true. Before I can factor the x out, what do I have to do?
do that.
Subtract the 3 over. Quadratics, right, Zach? We got to bring that over, set it equal to 0, and then factor it.
I don't like factoring the square.
Yeah, I know. How about we do quadratic formula then?
Yeah, I know that.
Okay, now. So right now I understand that my steps to solving are, okay, put in order, get everything on the same side, and then it's A, B, C, right? You guys with me so far? Okay, so instead of numbers, so I use numbers to just help me understand the stinking problem. Now I'm like, okay, I remember that I have to put the x squared first, and then the x, and then the constant. And when I saw this, it made me think quadratic formula. So can you guys help me write the quadratic formula, but instead of A, B, C, we have to use S, R, and negative T? Negative B plus or minus square root, oh shoot, I'm supposed to be using these letters. Negative R plus or minus square root,
Wait, R.
because that's B. A, B, C.
Wait, R would be B?
Minus 4A, C, all over 2A.
Wait, how do you figure out exactly what?
Because it was in front of the x. Like, okay, when I put y as x squared right here, but you gotta put it in order because quadratic formulas always go something x squared plus something x plus something. So I had to put the x squared in front, and then that was a. So once I put that in front, that's a. That goes in the middle, and then that goes last. But it was minus because I had to bring it over. From this step, you actually can figure out what the answer is. What's the answer? Okay, I love it. You guys narrowed it down to either F or H. One of those two.
How do you know that?
Well, because look what's inside the square root side. It's B squared minus 4AC. It's R squared. That all doesn't have R squared. Okay, you guys want to just take a 50-50 chance? What do you think? Ooh.
Wait. This one's a negative.
Negative, negative. There's another reason it has to be F. Okay? Let me tell you guys about quadratic formula.
I got it.
And specifically something called the discriminant. So I'm going to teach you guys this really quickly because I feel like your algebra teacher never taught you this.
Probably never did.
Okay. When you guys think of discriminant, that's what it's called. You think about the word discriminate. And discrimination is bad, right? Well, when you discriminate for a bad reason, it's bad. But what does discriminating really mean? Yeah, and outside of math, what does discriminating really mean? Like nothing. Based on their race or their gender or their whatever. It's putting people into categories, right? Male, female, I discriminated. Now it's treating them badly, but yeah. White, black, Hispanic, whatever. I'm discriminating. I'm separating you into little parts, right? Discriminating is just telling things apart into different things. Now, the discriminant tells us, that's not spelled right, but it doesn't matter. The discriminant tells us what type of solutions I'm going to have. This is pretty cool. Okay, the discriminant can be one of three things. It can either be a positive number, it can be 0, or it can be a negative. I discriminate between positive numbers, negative numbers, and 0. Okay? Now, if this is a positive number, I don't care if it's like 25, which is a perfect square, or 7, which isn't. How many answers do I get whenever I solve the quadratic formula? I always get 2 answers. Yeah, because I get the plus and the minus. Okay? Okay, let's say this was 0. How many answers would I get?
1.
I only get 1 answer. Because adding 0 and subtracting 0 is the same thing. And in terms of a graph, a quadratic with 2 answers looks like that. What does a quadratic with 1 answer look like?
It bounces. Right?
That. Yep, that's right. And then if it's a negative in here, so I'm square rooting a negative number, what do I have?
Imaginary.
Yes, I have 0 real, but I have 2 imaginary numbers. What does that look like on a graph? It going like that. Make sense? So my quadratic could have 2 answers, which is when the discriminant is anything positive. I can have 1 answer where it bounces if the discriminant is 0, and I can have 0 answers or 2 imaginary if the discriminant is negative. Okay? Which of the following will there be more than 1 solution, real numbers? So what does the discriminant have to be to get more than 1? It has to be positive. That's the only one that says positive. Between F and H. Positive. That. That's crazy, right? Is that tricky? I would never spend that much time on a question, but...
So leave that one for the end?
I mean, yes. Leave that one for the end. But it does help if you recognize that there's a quadratic formula piece in there. Anyway, okay. I want to talk to you guys really quickly about geometric and arithmetic sequences. I wrote them up last period.
I was thinking all day yesterday.
Okay?
I could try to.
Those of you in Calculus BC, our next unit is all about sequences and series, so I need you to know a difference between arithmetic and a geometric. And then we do crazy calculus with it. But just in general, sequences and series, there are two types that we typically look at. They're called arithmetic and geometric. Okay? Do you guys know, I wrote you an arithmetic series up there. Why is that an arithmetic series? What's it doing? It's adding a number every time. And what's it adding every time, this question? Right. Okay. Make sense? Okay, this is my first term. That's important. We call that A1. In almost anything, we call that A1. This is called the common difference. It's the thing you add every time. We call that D. And then we could get out to like A sub n, which is like the last term or whatever. Okay, or if I said, hey, find the 50th term. And there's formulas for this. You don't really need to, I don't want you guys memorizing formulas, so we'll talk about the different ways that you can do this. Okay, in a geometric, so how can you tell that this is a geometric series? Yep, it's multiplying by something, so it's actually growing exponentially, right? This is A1. And this, we call that R. That's known as the common ratio. Okay, so we call that R. Multiply by a ratio every time. Okay? So do you guys understand the difference between geometric and arithmetic series? We can spend like all day talking about this. Okay, so the thing that's kind of weird is that arithmetic turns into a linear equation because I'm adding 4 every time. This actually turns into an exponential equation.
What is an exponential?
Nothing. I don't know. Power series maybe? Anyway. But a geometric turns into an exponential series because look, the first term is 2 times 3 and I have 0 of them. And then it's 2 and I have 1. And then it's 2 times 3 times 3, which is 3 squared. 2 times 3 to the third, 2 times 3 to the fourth. So it makes an exponential equation. Okay? Anyway, we'll talk more about that later, even though it's so interesting. Check this out. Now, I think that you guys can solve this without me telling you any formulas. There are formulas, and if I was teaching a pre-calc class and I had time, we'd do a whole thing on this. Formulas, okay?
I got it.
No.
I got an answer that's not on there.
Okay? The third term is 13. The fourth term is 18. Could you guys help me find the first 2 terms? Yeah, because what's it doing right here? It's adding 5. So that's 8, and that's 3. Okay, so the first term is 3, the second term is 8, the third term is 13. What's the 50th term?
What? How does this make sense?
Look at it for a minute. So to get the second term, I take 3 and add 5. To take the third term, I get 3 and I add 5 twice. The fourth term, I take 3 and I add 5 3 times.
So you have 5 every time.
Boom. You add 5 every time. But, Aubrey, to get from the first to the 50th, how many times am I actually adding it? 49 times. Right? So I'm basically saying...
But what I did, 18 is the fourth, so then there's just 46 more times.
Okay, sure. So you added 3 46 more times. But not really, because you're only adding it 45 times, because from 4 to 5 is 1, from 5 to 6 is then 2, and so it's like 1 less.
That would give me a smaller number for this
No. Okay, so check it out. So start from the beginning because it's easier for me to explain.
45 times by 5.
Start with 3, and I'm adding 5. And how many times am I adding it? 49 times. Okay? So go back to the beginning, start with 3, and I'm adding 5 49 times. What do we get? Oh, the answer was 8. That's fine.
Okay, dude.
Yeah.
Yeah, the answer is 8.
I was doing it in every way, and I was like, I'm still getting the same answer.
For some reason, I thought it was C. I don't know why.
I know how you got C. It was times 5 plus 3.
Right. I just messing. Yeah, it is A. Now,
Mean.
you're welcome. Does that make sense if I were to tell you that the formula to find the nth term of an arithmetic sequence is A1 plus n minus 1d? That's the formula. And in the chapter on sequences and series, I'm having people memorize that formula, but does the formula make sense to you?
Yeah.
Start with the first term and add the common difference n minus 1 times. Okay? You want to see the formula for geometric? I bet you could get it, right?
Hold on.
I bet you could get geometric to get the nth term. Start with the first term, and then what am I doing? Describe it to me in words. I'm multiplying by r n minus 1 times, right?
Yeah.
R, and I'm doing it n minus 1 times. That's the formula for a geometric
Why is it
sequence.
n minus 1?
Because if I start at the first term and I'm going to the 50th term, I'm doing it 49 times.
Okay.
Because I'm starting at
Wait,
term
so
1
what
and not
does
term
n,
0.
does n represent like
The number of terms.
What does the weird slant represent?
Oh, I see. Okay. Oh, okay.
Where did I write a weird slant?
What the second one?
It's an R.
A1R. Weird slant.
Handwriting 1.
Common difference, common ratio.
It looks like a triangle. It looks like a
Anyways,
got square root.
cool. Yeah, so it's A. All right. Okay, don't say anything if you know this. Don't say anything. But let's say you're looking at this and you're like, hey, which of these is the graph of that? Like, I have no idea. Guess what? We have graphing calculators. Do you guys want to put that in your graphing calculator and see what the graph looks like? Can you do that? The hardest part is doing sine squared and cosine squared because you have to write the squared on the outside, but I think you can do it. Okay?
So how do you rate science weird?
So what you have to do is put the sign in parentheses and put a squared on the outside.
Oh.
So like I would put an extra set.
Oh.
I don't say anything, Zachary.
Oh, that. No, I just realized why that is.
I know.
That's so cool.
Guys, when I graphed it, I got that. What'd you guys get when you graphed it? Oh, it's on right above where the comma is. See where it's sign. Oh, let me see what kind of calculator you got. Is it graphing? Yeah, right there above the period, the comma is sign.
I got this.
Oh my gosh.
What does it look like?
A line.
That's what I got.
Oh, I got it right. Yeah.
H. Now,
Wait, so you just plug into this into the white.
Yeah, and I got H.
And hit graph, and it just shows you.
yeah. Now, why is this a number 54? Because number one, most people don't get to number 54 because they take up too much time on earlier ones.
That's so cool.
And number two, there is a way faster way of doing this.
That's just.
Zachary, you may now share with us what is the faster way of knowing the answer to this.
So basically, sine and cosine, they will. I don't know how to say this very well, but they're kind of opposites of each other. So when one is 0, the other one will be 1.
True?
They'll meet at 0.5. and
Yeah.
They'll go at 0 and 1 again, and they.
Right.
What ends up happening when you add them, you'll always get 1.
You add them, you always get one. When you square them and add them, you always get one.
Yeah.
Here's why. Okay? So first of all, if you ever do a trig class, the very first trig identity that you will ever learn is that. And almost all of trig identities is based upon this one trig identity. And here's how it works, okay? Can you guys think about the unit circle real quick? So you know when we make a unit circle? Let me make a unit circle. Ooh. Oh, look at how nice that is. Okay, right? And remember how we talked about how the x-coordinate is cosine and the y-coordinate is sine? We talked about that? Yeah? Okay, so it goes over cosine and up sine. Why is it called the unit circle? What does the word
One
unit mean? 1 unit. What is 1 unit?
1.
But what? What's 1?
The radius.
There you go. radius is 1. So guys, why does sine squared plus cosine squared equal 1? Pythagorean theorem. A squared plus b squared equals c squared. That's it. On a unit circle, sine squared plus cosine squared is 1. It's really cool because you know how, like, let's look at, like, at pi over 6, you guys. What's the sine of pi over 6? Remember your trig charts? 1/2. What's the cosine of pi over 6? Very good. Square those. What's 1/2 squared? 1/4. 3/4. What do I get? 4/4. It will always give you 1, no matter what. If you sine squared plus cosine squared, it always gives you 1, no matter what angle you're at. So if you know that identity, like if I had time and I got to the end of the test and I've taken a trig class, I'm all, oh, sine squared plus cosine squared equals 1. Boom. And I get that and I'm done. Okay? So that's not, like, terrible. This is a question that if you've just gotten out of a trig chapter with graphing, you would know how to do this really easily. If you haven't, you wouldn't. So I'll just tell you very quickly how graphs work, okay? All right. When I put a number in front of the sign, you guys know what happens to the graph?
Yeah.
What happens to it? Right? Let's put a 3 in front of it. Makes it go up to 3. Let's put a 5 in front of it. Makes it go up to 5. Right? You know what that's called?
Making it bigger.
Very good. But there's a word for it in math. Starts with an A.
Amplitude.
Amplitude. Let's freaking go. Why put that up to a 6? That has an amplitude of 6. Now, if I make it negative 6, it just flips upside down. Right? Negative. But the amplitude is still the same. Okay. So, I'm going to teach you guys something real quick that'll help you remember this. Alright. If I have an equation, okay, and if my equation is y equals a sine bx, this a right here is the amplitude. And specifically, the amplitude is an absolute value because it means the height. So whether it's going up or down, first, I don't care. That's the height, and that changes this. Okay? Now, do you guys know what b does? If you have, like, physics, you might remember this too.
Oh, I like physics.
The frequency, right? You have the amplitude and you have the frequency. So, for example, if I took my graph of sine, do you guys see that between 0 and 2 pi, that makes 1 full cycle?
What if the period?
Yeah, I'm going to show you right now. Okay? Let's say I put a 4 in front of that.
I think that's the length from.
I made more cycles, right? I made 4 cycles. Let's say I put an 8 in front of that. I just made 8 cycles between 0 and 2 pi. Let's say I put a 1/2 in front of that. I just made half of a cycle. Okay? That's called your frequency. Frequency means how many cycles it makes between 0 and 2 pi. So, B is the frequency. That's how many cycles it makes. Okay? But if I make 8 cycles in 2 pi, then what's the length of one cycle? 2 pi over 8. So the period is 2 pi over b. Because it's how many cycles, it's the frequency within one 2 pi period. Does that make sense? Kind of. So period is 2 pi over b. Now, this is only for trig functions that have a cycle of 2 pi, which are sine, cosine, cosecant, and secant. Those all have a period of, or a cycle of 2 pi. So 2 pi over b tells me what the period is. Period is how often it repeats, okay? What trig functions am I missing right here? Yeah, it's because tan and cotan actually have a cycle of pi. Okay, because look. Yeah, so let me show you. So here's my sine graph. Do you see how it takes me 2 pi to repeat an entire cycle? You guys see that? 1 up, 1 down. I can repeat an entire cycle in 2 pi. Look at the graph of tangent. Okay? How long does it take before it starts repeating its cycle? Only 1 pi. Because it goes like that, and then it repeats, and then it repeats every pi. So tan and cotan have periods of pi. Sine, cosine, secant, cosecant have periods of 2 pi. And then we just divide by b. That's the most amount of questions it will ask you on the ACT about a trig graph. And again, you guys, that could be like one question out of 60, like one. But with this group, because I know that you guys are like, right? You have to work on those one question to get yourself from like a 30 to a 35 or something like that, you know? That's how you get up into those really high ACT numbers, is you work on the one question. So looking at this one question, A is 1, so the amplitude would be 1. B is 4, so what's the period? 2 pi over b. Exactly. So now you see that? That's a super fast question. You guys do that very quickly, but it's a matter of, can you get to these in enough time, right? And do you remember trig graphs? Okay? Which honestly, I could have done a better job teaching it last year. We just didn't have time to go over everything. Ugh, it's the worst. I had to fill holes. Okay. This one, you guys are going to like this. I'm going to teach you what expected value is. All right? Expected value and probability. This is kind of fun, actually. Okay. We're going to play a game. And this is how the game goes, right? I'm putting a game at like a carnival or something. This is why this the subtitle of this mini lesson is called Why I Don't Gamble. Okay? Because I know too much math to gamble. I actually go to Vegas a lot.
Have you watched Scorpion?
No.
Have you seen Sylvester?
No. Wait, what is it?
It's Scorpion, and basically there are a whole bunch of geniuses.
I love it. I gotta watch. Is it a show or a movie? Okay, I gotta watch that. So, I actually do go to Vegas kind of a lot. My grandma lived in Vegas, so I visited her growing up, and I have a very lovely attachment to Vegas. Not because of the gambling, though, because, guys, guess what? The house always wins. It just is the way it is. I'm going to teach you what expected value is. We're going to play a game. Game goes like this. You roll a die, okay? If you roll a 1, you win $1. If you roll a 2, you win $2. If you roll a 3, you win $3. All the way up to if you roll a 6, you get $6. You can play as many times as you want, okay?
Sounds just like free money.
But in order to play the game, you got to pay me.
Oh, that's right.
Would you play the game if you paid me, if I charged $1 to play the game?
Yeah.
Not for sure.
Why would you not?
Right. If I charged you $7, would you play this game with me? No. Okay, what about if I charged you $2? Would you play?
It's only $1
$3, would you play? You wouldn't play with for $3? Would you play with $4, Ray? What do you think?
No, the best you can earn.
So definitely no. But you give me 4 and you roll a 6, you might get $6.
Actually, I would only gain
Okay.
$2.
So we're going to talk about the expected value of this game. All right? What chance do you have of rolling a 1? What probability? What about a 2? 1 out of 6, 1, 6, 1, 6, 1, 6, 1, 6. So what you do is you take this expected value, that times that. You guys already basically understand what this is. And you see, okay, so that's 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. And then you add all these up. Okay? So add all this up. So it's out of 6, and it's 6, 5, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21 out of 6. Right? If I add that up, 21 out of 6. The expected value of this game is 3.5. So if I charge less than 3.5, you should play. If I charge more than 3.5, you probably should. Right? Now there's an element of like guessing and stuff like that or whatever, right? Let's say we're flipping a coin. All right? We got this coin. And if you flip heads, I'm going to give you $20. That's what's up, right? But if you flip tails, you have to give me $5. And we can play as many times as you want. Are we playing this game?
Yes.
You have to pay to play.
No, we're not going to pay and play to play. We're just going to play. But if you get tails, you give me 5. But if you get heads, I give you 20. Are we playing this game?
I play this.
Heck yeah, because what's your... Thanks, buddy. What's your expected value? Well, you have a 1 in 2 chance of getting heads and a 1 in 2 chance of getting tails. So that's a 10. That's negative 2.5. Your expected value is 7.5. you are expected to get $7.5 from me. It's a good game, right? Does that make sense? That's all expected value is. So now look at this. See if you guys can find the expected value of this carnival game. Right? He tosses a penny, a nickel, a dime. You get 3 points if you get heads, 0 points if you get tails. Right? Now, do I need to write all this out? No, but this is the idea, right? My penny, my nickel, my dime. If I roll heads, I get 3 points. Tails, I get 0. With the nickel, heads 3, tails 0. The dime, heads 3, tails 0. If I multiply these together, so that's 3 over 2, 0 over 2, 3 over 2, 0 over 2, 3 over 2, 0 over 2. Add those all up. 9 over 2. That's my expected value. It's easy. There's nothing difficult about this, but again, you might get one expected value question, and in the last 10 questions, right? Okay, we've talked about matrices before. Again, you might get one matrix question, but it's not that hard. It's not too bad.
You don't need to know how to do it.
You do not need to know what a matrix is for this, because this is more a pattern question. The determinant of a matrix equals AD minus BC. So you guys, if I had a matrix that went 10, 2, 4, 5, what's the determinant of that matrix? How'd you get that? That times that minus that times that. How do I know that? Because it said A times D minus B times C. 42. Do you know what a determinant is? No. Does it matter? No. It's actually pretty cool. I can tell you, but it doesn't matter. You don't need to know that. So now that I know what a determinant is, because it tells me the pattern right here, what's the determinant of that? KK, K squared, minus 12 equals K. Now this is technically a quadratic. Bring it over, set it equal to 0, solve. But guys, we just plug these in and see which one works. If I plug in 3, is it going to work? 3 squared is 9 minus 12. Does that equal 3? No. Okay, what about if I plug in 4? 16 minus 12. Does that equal 4? Heck yes. And I'm moving on. Okay? We're good. So again, do you need to know what a determinant is? No. Do you need to know what a matrix is? No. You just need to be able to follow a pattern. Okay, we'll roll through these really quick. Guys, we talked about this so much. When I saw this on the practice test, I was like, let's go.
Yeah.
Given a positive integer n, I to the n equals 1, which of the following statements must be true? Do you guys remember we talked about I, where it goes, I to the 1 is I to the 2 is negative 1. It tells me right there in case I forgot. What's I to the 3?
Negative I.
Very good, because it multiplies I and I squared, right? What's I to the 4th?
1.
Because it squares I squared is 1. And then what's I to the 5th? Yeah, and then it goes I to the 5th, I6, I7, I8, I9, I10, I11, I12. This is something called mod 4. Every 4 it repeats, right? Modular 4. So every 4 it repeats. If it equals 1, what do I know about n? It has to be a multiple of 4. Which of these says multiple of 4? Yeah. That's what a multiple of 4 is. If I divide by 4, the remainder is 0. Okay, so it's got to be a multiple of 4. So we've talked about that a bunch. I thought that was a cool question. This is a very cool question. Okay, check this out. Like, think.
What?
All right, now hang on. This is the graph of sine. Right? You guys remember, we've talked about this. What happens when you absolute value a graph? What happens? Everything folds up to the positive side, right? So you with me that the absolute value of sine would be like this? Yeah? That's the absolute value of sine. Okay? Now your regular sine graph, you guys, where does it go from where to where? Top and bottom, like what's the range of your usual sine graph?
Negative 1 to 1.
Negative 1 to 1. So your sine graph goes here to here. Negative 1 to 1, right? So that's negative 1, that's 1. Okay, so this graph, when is it greater than or equal to 1? Guys, is it ever greater than 1? No. So if it just said greater than 1, never. Is this ever equal to 1?
Yes.
Where?
Negative pi over 2.
There. Yeah, all the way across there. So pi over 2, negative pi over 2, negative 3 pi over 2. And then it would go to 5 pi over 2, 7 pi over 2, all the pi over 2s. But it says only between negative pi over 2 and pi over 2. So what's the answer? A. Because it does happen in 2 places. It happens in multiple places, but it's obviously not all the points. And what does the empty set mean? That means if it's nothing. So for example, if I had said when is it greater than 1? Empty set. It never is. But greater than or equal to, well, it is equal at a few certain points. Last one, this is not that bad if you have to draw it. I was kind of surprised to see this as a number 60 because 60 is usually the hardest. This isn't that hard. Can you guys draw an angle LPM? LPM. And a ray bisecting it. Ray, do you know how to bisect? No. Do you know what you are? You know what a ray is? It's a line with an endpoint and an arrow on it, so it's not like a line. A line goes forever both directions. A ray goes in one direction. Anyways, I was thinking about you, Ray, during first class. I was like, Ray? It's like, oh, Ray's coming today. All right. So look. LPM is 11x, the whole thing, right? LPK is 4x plus 18, and this was like K. Can you guys solve that? What would you do to solve that? What equation would you use?
11x minus 4x plus 18, right?
That would be weird. Equals what?
Never mind. Forget on top.
Well, I'm moving another variable in there, which would suck. Now, it does say this bisects. What does the word bisects mean? Exactly in half? Would that also be 4x plus 18? Oh, and now you can figure it out. You can do 4x plus 18 plus 4x plus 18, or you can just do 2 of them and solve it, right? So if I go 11x, that's 8x plus 36. Subtract that over. 3x is 36, x is 12. And then what do I do, guys? I go, whoo, I'm done.
No,
yes.
you don't.
No, I don't, because this is question 60.
12.
Because you guys, I got to go back and read what it wants. What is the measure of? Oh, crap. X is 12, right? Now look, if x is 12, what's the whole big angle? 132. What's this angle? 66. What's this angle? 66. KPM. 66. Let's go. How you guys feel? You feel all right?
Why is that not an answer?
Good stuff. What? Okay? Now, guys, really, and I know that you probably won't do this until maybe like the weekend before, and that's fine, because we got this week and a couple days and then ACT. At any point, if you want me to email you a bunch of ACTs and you just want to do the last 20 questions or the last 10 questions, that's how you're going to be able to get fast to get these. Make sense?